In this video, we're going to be solving some inequalities that involve absolute value. But before I give you the rules to follow, let me kind of explain why those rules are the way they are, give you some motivation. I mentioned in the last section, when we were talking about absolute value equations, that you can think of the absolute value of a number as representing how far that number is from zero on the number line. So if the absolute value of a number is 3, that means that that number is 3 units away from 0. If the absolute value of a number is less than 3, that means that that number is less than 3 units away from 0. So where could you be if you're less than 3 units away from 0? You're closer to 0 than 3 units. So that means you could be less than 3 units away to the right, less than 3 units away to the left. That puts you somewhere between negative and positive 3. You're less than 3, but you also have to be greater than negative 3. So you have to be between negative 3 and 3. So for the absolute value of a number to be less than something, that number has to be between negative and positive something. It has to be less than that positive number, but it also has to be greater than, not less than, but greater than that negative number. So the rule is, whenever you see the absolute value of some expression less than some number, you can translate that into negative number less than expression less than number. In other words, the expression is between the negative and the positive of that number. And if it was originally not just a less than, but a less than or equal to, same rule, but with less than or equal to's. So let's look at some examples. The absolute value of x is less than 8. So we have to immediately take the expression inside the absolute value bars, which in this case is just x, and put it between negative and positive 8. We translate absolute value of x less than 8 into negative 8 less than x less than 8. So notice that part of this looks like this, but without the absolute value bars. But we also had a negative 8 over here being less than the x. So here's what x can be. It can be any of these numbers between negative 8 and 8. Could be 7, could be negative 7. Could be 3, could be negative 3. Could be 1, could be negative 1. Any of those numbers would have an absolute value that's less than 8. It could not be 10, and it could not be negative 10. Because in either case, the absolute value would be 10, which is not less than 8. So the solution set looks like this. It's the interval from negative 8 to 8. Everything between negative and positive 8. How about this? The absolute value of 2x minus 3 is less than or equal to 7. So what does that tell you about 2x minus 3 itself? What has to be true about 2x minus 3? Well, it has to be between negative 7 and positive 7. So I would write negative 7 is less than or equal to 2x minus 3 is less than or equal to 7. Notice how part of this is exactly what we started with, but without the absolute value bars. But then 2x minus 3, it has to be on the small side of 7, but it has to be on the big side of negative 7. It has to be between negative 7 and 7. Now we have to finish solving this for x. We have to go from 2x minus 3 to just an x in the middle. And there's 3 sides here, so we have to do the same thing to all 3 sides. First, I'll get rid of the minus 3 by adding plus 3 to all 3 sides. Negative 7 plus 3 gives me negative 4. 2x minus 3 plus 3 gives me 2x. And 7 plus 3 gives me 10. Now I'll go from 2x to just x by dividing by 2 on all three sides. Negative 4 divided by 2 gives me negative 2. 2x divided by 2 gives me x. And 10 divided by 2 gives me 5. I divided by a positive number, so these signs are still pointing the same direction. They're still less than or equal to signs. So we ended up with x being between negative 2 and 5. Negative 2 is less than or equal to x is less than or equal to 5. Here are the numbers on the number line that fit that description. These are the numbers that are between negative 2 and 5, including negative 2 and including 5. And in interval notation, this would be the interval from negative 2 to 5. Now what about this? The absolute value of 5x plus 9 is less than negative 14. If this were a positive 14, we'd just set it up as negative 14 less than 5x plus 9 less than 14. But since this number is already negative, this is telling us that the absolute value of something is less than a negative number. Can that happen? Is it possible for the absolute value of something to be less than negative 14? No, it's not. The only numbers that are less than negative 14 are all negative numbers. Things like negative 15, negative 20. And absolute value can't be negative. So this cannot happen. This has no solution. Okay, so we've looked at situations where we have the absolute value of some expression less than, or maybe less than or equal to, some number. What about if we have the absolute value of some expression greater than, or maybe greater than or equal to, some number? Going back to our distance setup, we said you can think of the absolute value of a number as how far that number is from 0. It's distance away from 0. If that distance is greater than 3, the absolute value of x is greater than 3 means that x here is more than 3 units away from 0. Look at this number line and figure out, okay, which numbers are more than 3 units away from 0? There's a mean dog chained up here at 0, and the length of the chain is 3 units. Where can you stand to be safe from the dog? Anywhere that's more than 3 units away from 0. Where's that? Well, we got some numbers over here, 4 and 5 and 10, and basically anything past 3, anything that's greater than positive 3. But we also have some numbers over here that are past negative 3 in this direction. That would mean that they are less than negative 3. Things like negative 4 or negative 10. So for the absolute value of x to be greater than 3, that means x is greater than 3 or x is less than negative 3. So the rule here is whenever you have the absolute value of some expression greater than some particular positive number, that translates into, okay, the expression is greater than that number, or that expression is less than the negative of that number. If it's a greater than or equal to, same rule, but with or equal to's on your inequalities. So let's say, for example, we have the absolute value of 3 minus x is greater than 2. The absolute value of this expression is greater than this number. So that turns into the expression 3 minus x is greater than 2, or that same expression 3 minus x is less than negative 2. Notice that these are pointing opposite directions. Very important. You can be greater than 2, or you can be less than negative 2. So one of these looks exactly like what we started with, but without the absolute value bars. The other has the same expression, It has the negative of the number, and the inequality is pointing the other way. We're either greater than 2 or we are less than negative 2. Now we got to finish solving these for x. So I'm going to subtract 3 on both sides. Negative x is greater than negative 1. Here, if I subtract 3 from both sides, negative x is less than negative 5. And to go from negative x to just x, I'm going to divide by negative 1. But since I'm dividing by a negative number, the inequality gets reversed. X is less than, and then negative 1 divided by negative 1 would be positive 1. Or x is greater than, and then negative 5 divided by negative 1 would be positive 5. So x is less than 1 or x is greater than 5. What does that mean? Where are we on the number line? Well, we could be either over here less than 1 or over here greater than 5. By the way, this is saying that x, the distance between 3 and x, is greater than 2. So x is a number that's more than 2 units away from 3. Might be more than 2 units away this way, might be more than 2 units away this way. But it's some number that's more than 2 spaces distant from 3. That means it's part of the interval from negative infinity to 1, or it's part of the interval from 5 to infinity. So the solution set altogether is the interval from negative infinity to 1 together with the interval from 5 to infinity. And this symbol here, this U-looking thing, is the symbol for one set or one interval together with another. We call that union. And you don't have to write that symbol, but that's what the book uses, and that's what I'll use. So when you're taking everything in one interval together with everything in the other and making the solution set both of those together, I'm going to write that with this union symbol. Let's try another example. The absolute value of this expression, 5x, is greater than or equal to this number, 10. So for the absolute value of something to be greater than or equal to 10, the something has to be greater than or equal to 10, or it has to be less than or equal to negative 10. 5x is greater than or equal to 10, or 5x is less than or equal to negative 10. To finish solving those for x, divide both sides by 5. X is greater than or equal to 2, or x is less than or equal to negative 2. So here we are on the number line. X could be anything that's greater than or equal to 2, or anything that's less than or equal to negative 2. In interval notation, these are 2 separate pieces, but we take both of them together to make up the solution set. So this would be the interval from negative infinity up to and including negative 2, together with, or union, the interval starting at 2, including 2, and going up to infinity. I'm going to end this section with a couple of word problems, but I'm going to save those for another video. I'm going to make one more short video where we go through a couple examples of word problems.